Hey guys, welcome to question MM235 of the Maths Methods Fortify study guide. Now we've got this line XY, so XY down this way, and it encloses a rectangle OABC, so this rectangle here, as shown in the diagram below. The coordinates of B are AB, and we need to find in part A, we need to find A and B in terms of X. Awesome. So, first things first is we know that AB are our XY coordinates, which means that this is like this, which means that A is simply going to be our X value, right? Which means that A is equal to X. That's fine. That's actually our first mark. So this part of it is quite straightforward, but our second mark is going to come when we find B in terms of X. So how do we do that? Well, firstly, we actually need to find what the equation of this line is in order to figure out our Y value based on our X value, right? So firstly, we know that in order to figure out the equation of a line, we need our gradient and our C value, okay? So our gradient is going to be equal to rise over run, which is y2 minus y1 over x2 minus x1. As always, guys, you would have seen this a million times by now. Let's say that y2 and x2 is this coordinate here. So we get 4 minus 0 over 0 minus 2, which equals 4 on 2, which is 2. Sorry, 4 on negative 2, which is negative 2. So our gradient is negative 2, which means that in our y equals mx plus c form, we get y equals negative 2x plus c. And keep in mind that our c value is our y-intercept. That means that our y-intercept is 0, 4, so our c value is 4. So our equation is y equals negative 2x plus 4. Awesome. So any y value along this graph, or along this line, xy, is equal to negative 2x plus 4, which means that our b value is our y value, so therefore, b is equal to negative 2x plus 4. That's our second mark. That's part A. Let's move on to part B. So part B is a 3-mark question. Well, part BI is a 3-mark question. And what we need to do is find the coordinates of B for which the shaded area above is at a maximum. Awesome. So we need to find this coordinate such that this shaded area is at a maximum. All right, so if we're trying to figure out the maximum area, what we're going to need to do is come up with an equation for that area based on our B coordinate, right? So we know that from our previous question that B lies at AB, which is x negative 2x plus 4, right? We found that in our previous question. So what that means is the area of this shaded area we're going to need to come up with an equation for. So there's 2 ways we could do this. We could figure out our area of this triangle, area of this triangle, and then add them together, or we can figure out the area of this larger triangle and then minus the area of the rectangle. I'm going to do that one. I'm going to find the bigger area of the triangle and then minus this rectangle. So we know that this length here is 2, because we know that's 2, 0. We know this length here is 4, because this is 0, 4, which means that the area of our large triangle, so area of large, is equal to half base times height, which is equal to half times 2 times 4, which is equal to 4. So our large triangle has a area of 4, and we need to find the area of this rectangle now to minus that. So our area of our rectangle is equal to length times width. Our length is equal to x, right, because this is our x value here, and then our width, or our height, is equal to our y value, which is negative 2x plus 4. Sweet. Which gives us negative 2x squared plus 4x. Now what do we need to do? We need to minus them. So our total area, or our shaded area, I should say, is equal to our large area, this whole triangle, minus our rectangle. So minus rectangle, which equals 4 minus negative 2x squared plus 4x. So we get 4 plus 2x squared minus 4x, and I'm just going to rewrite this because I like having the quadratic in the proper format. 2x squared minus 4x plus 4. What we can do as well is take out the common factor of 2, but it doesn't really matter. It's up to you. Because that's not what our final answer is going to be. We're still going to need to figure out our derivative. So the fact that we found our area, or our area formula, is our first mark out of the 3. All right. So from here, if the area is at a maximum, that means that our derivative function of our area is equal to 0, which means we're going to need to find our derivative function. So a dash of x is equal to the derivative of this. So this 2 comes out the front, and we get 4x minus 4. We know that this has to equal 0 because it's at a maximum. So 0 equals 4x minus 4. So x equals 1. Awesome. That's our second mark. So figuring that out, get our second mark. But we still need to actually find the coordinates of b. So we found the x value at b, which is 1. But now we need to find our y value because we need to find the total coordinate. We know that our y value, or our b value, is given by negative 2x plus 4, which means that we can sub in our x value, which means negative 2 times 1 plus 4 is equal to 2, which means that b lies at 1, 2, at max area. So you can write at max area, and that'll just solidify that you'll get the mark. That's our third mark, final answer. And that's it. So the biggest thing, guys, is again, whenever you see the word maximum, you're deriving the function, making it equal 0, and solving for x. Awesome. Let's move on to part BII. So, as before, our this is 1 mark. So, as before, our area was given by 2x squared minus 4x plus 4. Is that what it was? Yeah. Awesome. And we're trying to find the area. So we know that the x value at the maximum area is equal to 1, because b was at 1, 2, which means that our x value at maximum area is 1, so we simply need to sub in 1 for our x value. So 2 times 1 squared minus 4, 1 plus 4, gives us 2 minus 4 plus 4, which is equal to 2. So area is equal to 2 units squared. This is our final answer and first and only mark for part BII. And that's actually it for question MM235. So if you have any questions, hit me up in the comments below. But otherwise, thanks for watching, and we'll see you in the next video.